Hey guys, welcome back to AP Chemistry. This is podcast 4.2, and it's all about exothermic and endothermic processes. So you'll be experts at this already, I can already tell. So let's look at the universe. The universe is divided into two separate halves. They're not equal. One half we call the system, the other half is called the surroundings. Only two parts to keep track of. How easy is that, right? And so the system is the part that you're concerned with, whether it's in your beaker or just two atoms, or the part that we are interested in our scientific experiment. And the surroundings are all the rest. Everything that's not the system we consider to be the surroundings. So in thermochemistry, we're concerned with energy transfers between the system and the surroundings. So let's look at our prefixes. Exothermic. Reactions release energy from the system to the surroundings. So if we are concerned with the system, then exothermic describes energy that will exit away from the system, right? Endothermic processes describe energy transfers that bring energy into the system from the surroundings. So that's what your prefixes mean. We're going to make sure we keep those straight because it's going to make a difference in the sign that you see. So if you know that's a process where energy is gained by the system, then you better make sure you've got the right sign on your work. All right, well, let's look at an example here. I have energy in my system, and it's going to move from the system out into the surroundings. So how would we describe this energy transfer? First of all, it left the system, right? So that was an exit. That would be exothermic. So if this is an exothermic process, then what's the sign for your energy change going to be? Well, the system's energy went down, right? Because energy went to the surroundings from the system. That means our energy change is less than 0, which makes it a negative number. So far, so good. All right, then. Let's look at a different example. Now, in this case, the energy is going to move from the surroundings into the system. So now the system has gained energy, right? Energy moved into the system. That's an endothermic process. So what's the sign for your energy change? For the system, the amount of energy has increased. So that had better be an energy change that is greater than 0. That's a positive energy change. So if I describe a real-world situation like ice melting, I need you to consider what's the system, what's the surroundings, and how is the energy going to move from the surroundings to your system. All right, now let's look at the conservation of energy. Clicking the wrong buttons here. Of course, we just talked about the first law of thermodynamics, that the amount of energy in the universe stays constant, the amount of energy transferred between objects has to stay constant too. So here's another way of expressing what energy is. Remember I said energy is heat plus work? And check this out. Remember Q from last year? Q is mc delta T. Q is heat, which is equal to enthalpy at constant pressure. So if energy is Q plus W, that would be heat plus work, just like we already said. Some of it is useful energy, used to do work. Some of it is heat. And W, of course, is the work done on the system, not on the surroundings. And Q is heat liberated from the system. So watch your signs, endothermic and exothermic processes. It's important to keep track of positive signs and negative signs. So reactions that give off heat are called exothermic. What we'll see in the surroundings is that the temperature increases in the surroundings. That's the part that's easiest to measure, right? You can measure what's going on in the water of your beaker a lot easier than in the atoms themselves. Yeah? And so reactions that absorb heat are called endothermic reactions. And if it's taking energy from the surroundings, then the temperature of the surroundings is going to decrease. So for the surroundings, the temperature decrease is going to be measured. And this is true for whatever kind of process. It doesn't have to be a reaction. It can be melting or condensation or freezing or any of those processes. It can even be just changing the temperature of something, right? Where you touch something that's cold and the energy moves from your body to the cold object. Well, then we'll see a temperature decrease from you and increase in that object. And that's it. That's endothermic and exothermic. See you guys later.